So this is the last section of chapter 10. Circles, sectors, and segments. Well, the area of a circle, hopefully by now, we all know how to calculate the area of a circle, so I'm not going to go into a lot of detail. We've talked about it already. Area of the circle. How do we find the area of a circle? Pi r squared. And our units are square units. And r is the radius. And we've worked with this formula before, so I think we should be good. Just remember one thing that I see sometimes is students want to square everything. You just square the radius. Use the area of a circle. All right, so we've worked with this before. I'm not going to go through an example of finding the area of a circle. Pi r squared. That's how we find the area of a circle. The next thing we need to know is what is a sector of a circle. Well, sector, we can think of a sector as a slice of pizza. So there's my circle. I'm going to take a chunk out of that circle. I'm going to call this R. The center of the circle is P, and this point is S. The sector is the shaded part. We can think of a slice of pizza, a piece of pie, something. So the shaded part is a sector. And we name a sector the same way we name angles. So I'm going to call it sector RPS. The number here, or the letter there in the center, in the middle, is the center of the circle. Just like with an angle, that middle letter has to be the vertex of the angle. And the sides of the sector are radii. That's a radius, and that's a radius. Well, the area of a sector is a fraction of the whole area. Well, the fraction is the same fraction that we use for arc length. So we're going to find out what portion of 360 that arc takes up, and that's going to tell us what fraction of the circle that sector takes up. So here, instead of multiplying by the circumference, when we talk about arc length, we're going to multiply by the area of the entire circle. So we're using the same fraction as we did for arc length. So let's write our formula. Area of a sector. Let me draw a picture. Here's my circle, and we're going to make sector AOB. So the center is at O, that's B, the radius is R, and we're talking about this shaded part in here. The area of sector AOB is the measure of arc AB, the angle measure, divided by 360 times pi r squared. And our units are going to be square units. This part tells us the fraction of the circle. And this part is the area of the circle. So we're multiplying the area of a circle by a fraction. The fraction is, well, how much of the circle does that thing take up? And this arc over 360 is the same fraction that we use for arc length. So it's a very similar calculation. But here we have pi r squared. We have the area of the circle instead of the circumference of the circle. So let's look at an example. Here's my circle. Whoops. Let me get rid of that little circle. There we go. So we're going to say that's 84-degree angle. The radius is 9 millimeters. And I'm going to call this TSR. We want to find the area of sector TSR. Well, the area is the fraction of the circle that takes up. So our area is going to be 84 degrees over 360 degrees. That tells us what fraction that takes up, times the area of the circle, times pi times 9 squared. 84 divided by 360, when I calculate that out, I get 0.233. 9 squared is 81. And if I multiply 0.233 times 81, I would get 18.9 pi square millimeters. That would be my answer in terms of pi. So I divided 84 by 360, multiplied it by 81. If I plug this all in my calculator and round it to the 10th, that'd be about 59.3 square millimeters, rounded to the 10th. All right, questions there? Okay. Last thing we need to know is about segments of a circle. Well, a segment is kind of, we can think of a segment kind of like a piece of the crust of the pizza. So I'm going to cut out a sector, but then we're going to cut that off there. So I'm going to shade this in. This portion is a segment. And we already know how to find the area of a segment. We just maybe don't realize it. So I'm going to draw a little picture here to give us a visual. The area of a segment, I'm going to draw 3 circles here. And they're all supposed to be the same circle. And I'm going to make an equation with those circles. So all right, so the area of a segment. We're going to find the area of the sector first. So we're going to find that area. Then we're going to find the area of this triangle. and we're going to subtract those. So the area of the sector is this whole thing. We're going to subtract the area of the triangle, and that's going to leave us with the area of the segment. So the sector minus a triangle equals the segment. We just talked about how to find the area of a sector. We know how to find the area of a triangle, base times height divided by 2. So we subtract those two, and that's going to give us our segment. So when we find the area of a segment, we're going to have some kind of information, enough information to find the area of a triangle. So we need to be able to figure out the base and the height. Well, the base is always a radius. We need to be able to figure out the height somehow. All right, questions there? So let's look at a couple of examples, and then we'll be done with chapter 10. All right, so there is our angle. There's our sector. We want to find the area of that shaded segment. And I'm going to say the radius here is 7 inches. Well, we need two things. We need the area of the sector. Well, how much of a circle is 90 degrees? 1/4. So 90 divided by 360 is 1/4. It takes up 1/4 of the circle. So the area is going to be 1/4 of pi times 7 squared. 7 squared is 49. And I divide that by 4. So that's 1/4 of 49 times pi. And that would be 12.25 pi square inches for the area of the sector. And that's approximately 38.5 if I calculate that out. So that'd be that segment, or the sector, sorry, rounded to the 10th. We need the area of the triangle also. Well, we know the area is the base times the height divided by 2, and that's a 90-degree angle. So what's the height of this triangle? 7. That's also a radius. So that's 7 times 7 divided by 2. So 49 divided by 2. 7 times 7 is 49 divided by 2, which is 24.5 square inches. So the segment, the area is the area of the sector, 12.25 pi minus 24.5 square inches. If they wanted our answer in terms of pi, we just have to leave it like that. That's approximately 38.5 minus 24.5, which is 14 inches squared. So rounded to the 10th, that's going to be about 14 square inches, the area of that segment. And this one we were able to figure out the height because the height was also a radius. All right, let's look at one more example where we get a visit from an old friend here. There's my circle. Say my radius is 6 centimeters. And this angle, this arc, is a 60-degree arc. And we want the area of that segment. Well, we know that the area of the segment is the sector minus the triangle. So we need to find the area of the sector. Area of the sector, we need to know what fraction of the circle that sector takes up. Well, the fraction is 60 over 360 times the area of the circle, pi times 6 squared. What's 60 over 360? 6, or 1/6, right? I could get rid of those zeros. 6 over 36 is 1/6. So this is equal to 1/6 of 36 pi. And 1/6 of 36 is 6. So that would be 6 pi square centimeters for the area of the sector. The area of the triangle. Well, we know the base is 6 centimeters, but this isn't a 90-degree angle. So we have to draw in the height. There's my height. Well, if this is a 60-degree angle, these are both radii. What kind of triangle does that make this? This would be 60 degrees. This would be 60 degrees. This whole angle would be 60 degrees. That's an equilateral triangle. When I draw in the height of an equilateral triangle, it divides it in half. So this piece is 3, and that's a 30-degree angle. So to find the height, we need to go from the short side to the long side. So what do you do to go from the short to the long? Multiply by the square root of 3. So our height for our triangle is 3 square root 3. The area is the base, 6, times the height, times 3 square root 3. 6 times 3, and we're dividing it by 2. 6 times 3 is 18, divided by 2. So we get 9 square root 3 square centimeters. So the area of the segment would be 6 pi minus 9 square root 3 square centimeters. If we wanted an exact answer in terms of pi, answer in simple radical form, that's what we'd get. If we wanted to round to the 10th, we'd plug that in the calculator. So when we calculate that, 6 pi minus 9 square root 3. And I get 3.3 if we round to the 10th. Square centimeters. All right, questions? Yeah.
For the area of the triangle, do you just forget about the 6 pi, to find area?
About this one?
No, I see what. Never mind. Sorry. No, I get it now.
Okay. Yeah, here
Yeah.
that's the area of the triangle minus the sector minus the triangle.
Yeah.
Okay. All right. Homework. All right, we have, I'll answer any questions we have on homework. We have almost a half an hour. So let's get 8 through 24 even done, and stamped by the end of class.